Resources, Part 1. You already know that 3/4 of the Earth's surface is covered with water, but only a small proportion of it accounts for fresh water that can be put to use. This fresh water is mainly obtained from surface runoff and groundwater that is continually being renewed and recharged through the hydrological cycle. All water moves within the hydrological cycle, ensuring that water is a renewable resource. You might wonder that if 3/4 of the world is covered with water and water is a renewable resource, then how is it that countries and regions around the globe suffer from water scarcity? Why is it predicted that by 2025, nearly 2 billion people will live in absolute water scarcity? Water scarcity and the need for water conservation and management. Given the abundance and renewability of water, it is difficult to imagine that we may suffer from water scarcity. The moment we speak of water shortages, we immediately associate it with regions having low rainfall or those that are drought-prone. We instantaneously visualize the deserts of Rajasthan and women balancing many mud cars or earthen pots used for collecting and storing water and traveling long distances to get water. True, the availability of water resources varies over space and time, mainly due to the variations in seasonal and annual precipitation. But water scarcity in most cases is caused by over-exploitation, excessive use, and unequal access to water among different social groups. Where is then water scarcity likely to occur? As you have read in the hydrological cycle, fresh water can be obtained directly from precipitation, surface runoff, and groundwater. Is it possible that an area or region may have ample water resources but is still facing water scarcity? Many of our cities are such examples. Thus, water scarcity may be an outcome of large and growing population and consequent greater demands for water and unequal access to it. A large population means more water, not only for domestic use, but also to produce more food. Hence, to facilitate higher food grain production, water resources are being overexploited to expand irrigated areas and dry season agriculture. You may have seen in many television advertisements that most farmers have their own wells and tube wells in their farms for irrigation to increase their produce. But have you ever wondered what this could result in? That it may lead to falling groundwater levels, adversely affecting water availability and food security of the people. Water resources, Part 2. Post-independent India witnessed intensive industrialization and urbanization, creating vast opportunities for us. Today, large industrial houses are as commonplace as the industrial units of many MNCs or multinational corporations. The ever-increasing number of industries has made matters worse by exerting pressure on existing freshwater resources. Industries, apart from being heavy users of water, also require power to run them. Much of this energy comes from hydroelectric power. Today in India, hydroelectric power contributes approximately 22% of the total electricity produced. Moreover, multiplying urban centers with large and dense populations and urban lifestyles have not only added to water and energy requirements but have further aggravated the problem. If you look into the housing societies or colonies in the cities, you would find that most of these have their own groundwater pumping devices to meet their water needs. Not surprisingly, we find that fragile water resources are being overexploited and have caused their depletion in several of these cities. Now let us consider another situation where water is sufficiently available to meet the needs of the people, but the area still suffers from water scarcity. This scarcity may be due to bad quality of water. Lately, there has been a growing concern that even if there is ample water to meet the needs of the people, much of it may be polluted by domestic and industrial wastes, chemicals, pesticides, and fertilizers used in agriculture, thus making it hazardous for human use. You may have already realized that the need of the hour is to conserve and manage our water resources, to safeguard ourselves from health hazards, to ensure food security, continuation of our livelihoods and productive activities, and also to prevent degradation of our natural ecosystems. Overexploitation and mismanagement of water resources will impoverish this resource and cause ecological crisis that may have profound impact on our lives. Rainwater harvesting, Part 1. In ancient India, along with the sophisticated hydraulic structures, there existed an extraordinary tradition of water harvesting system. People had in-depth knowledge of rainfall regimes and soil types, and developed wide-ranging techniques to harvest rainwater, groundwater, river water, and floodwater in keeping with the local ecological conditions and their water needs. In hilly and mountainous regions, People built diversion channels like the Gulls or Kuls of the Western Himalayas for agriculture. Rooftop rainwater harvesting was commonly practiced to store drinking water, particularly in Rajasthan. In the floodplains of Bengal, people developed inundation channels to irrigate their fields. In arid and semi-arid regions, agricultural fields were converted into rain-fed storage structures that allowed water to stand and moisten the soil, like the Khadins in Jaisalmer and Johads in other parts of Rajasthan. Rainwater harvesting. Part 2. In the semi-arid and arid regions of Rajasthan, particularly in Bikaner, Phalodi and Barmer, almost all the houses traditionally had underwater tanks or tankas for storing drinking water. The tanks could be as large as a big room. One household in Phalodi had a tank that was 6.1 meters deep, 4.27 meters long, and 2.44 meters wide. The tankas were part of the well-developed rooftop rainwater harvesting system and were built inside the main house or the courtyard. They were connected to the sloping roofs of the houses through a pipe. Rain falling on the rooftops would travel down the pipe and was stored in these underground tankas. The first spell of rain was usually not collected, as this would clean the roofs and the pipes. The rainwater from the subsequent showers was then collected. The rainwater can be stored in the tankas till the next rainfall, making it an extremely reliable source of drinking water when all other sources are dried up, particularly in the summers. Rainwater or palar pani, as commonly referred to in these parts, is considered the purest form of natural water. Many houses constructed underground rooms joining the tanka to beat the summer heat, as it would keep the room cool. Part 3. Today, in western Rajasthan, sadly, the practice of rooftop rainwater harvesting is on the decline. As plenty of water is available due to the perennial Rajasthan canal, though some houses still maintain the tankas, since they do not like the taste of tap water. Fortunately, in many parts of rural and urban India, Rooftop rainwater harvesting is being successfully adapted to store and conserve water. In Gendathur, a remote backward village in Mysore, Karnataka, villagers have installed in their households rooftop rainwater harvesting system to meet their water needs. Nearly 200 households have installed this system, and the village has earned the rare distinction of being rich in rainwater. Gendathur receives an annual precipitation of 1000 millimeter, and with 80% of the collection efficiency and of about 10 fillings, every house can collect and use about 50,000 liters of water annually. From the 20 houses, the net amount of rainwater harvested annually amounts to 1 lakh liters.